Hey everyone, this is Michael, and I'm going to go over the Crowdsale contract that I did on August 20th, in case you missed it. It's a simple crowd sale, and the code is on GitHub. I'll post the link to it on the description of the video, but it's github.com/TBBD, Tampa Bay Blockchain Developers. So with that out of the way, let's get started. So as you can see here, I've made a directory called Simple Crowdsale, and I'm going to go ahead and do a truffle init, which if you saw the previous video, I went over what truffle is and how that works. The directory was empty, and now it's not. Now it's got the base truffle information that it needs. I'm going to go ahead and open it up right here and maximize that. And as you can see here, truffle just gives me all these contracts and some migration files, some JavaScript files that help migrate the code to the blockchain. And it's also got some testing cases for these pre-made contracts. Now what I'm going to do is I'm actually going to get rid of most of the stuff. So I'm going to go into the contracts folder and see what's in here. Convert lib and metacoin. I don't need either of them, so I'm going to go ahead and remove both of them and remove metacoin. These are both default contracts that you can actually use and test. Metacoin is a default like kind of an ERC20 token. It's not the standard, but it does create a token that you can test with and send across. And convert does some mathematical conversions, but we're not going to be using any of those, so I'm just going to go ahead and remove them. All right, get out of there, and let's go into the migrations folder, and let's delete the deploy contracts.js as well. So I'm gonna go ahead and remove that. All right, get out of here, and let me go ahead and just remove the tests, even though we're not gonna be using them anyway. So here, cd test, and remove test metacoin, and remove metacoin.js as well. Okay, perfect. Now that the project is set up, we can go ahead and create the Crowdsale folder, or the Crowdsale.solidity file that we're going to make. So truffle has a command truffle create contract, and we're going to call it Crowdsale. And with that, it's been created. We can actually see it right here. And it just gets us the basic solidity, and it creates the contract itself, and then it's got the constructor function with the contract. So to do this Crowdsale contract, we're going to have a couple parameters. We're going to have it have a minimum and a maximum. It needs to have a start time and an end time. It needs to have a project address that we're going to send the funds to. We're also going to keep track of the balances and the total transferred in the project. So let me write all that down so I don't forget it. So we're going to go with the variables are, actually I'll do that up here, variables. So we need balances, we need the total transferred, we need to keep track of the project wallet, and we also need to keep track start, end, and minimum, maximum as well. These are the variables that we're going to need. So to start with the balances, we're actually going to do something called a mapping, which is like a hash map, dictionary, depending on your language. And it's a key value pair. So the key is going to be an address, and there's going to be a value associated with that address. Value, yeah, no. That value is going to be a uint. And we're going to call this balances as well. So with this, then we're going to make it public as well. So this is just a key value pair. We're going to save an address, and there's going to be an associated amount, integer. So every time someone transfers money, we're going to increment this uint, or we're going to increment the amount associated with the address. We also need the transferred total, which we're also going to keep track of, and we're just going to go ahead and set that to 0 right there. And this is, we're going to keep track of that as every time someone sends Ether to the contract. And we also need a address that's going to be the public, the project wallet. So we're going to call it project wallet, just like that. And actually, let's go ahead and get the project wallet right now. And what I'm going to do is I'm going to go ahead and run geth on my computer right now. We're going to deploy this on the rinkb test net. So I'm going to go ahead geth rinkb, and we're going to do RPC API, and we're going to go ahead and do db net web3 personal, and I'm missing one that I can't remember. And F, there we go. Okay, now with that, we should be able to get this going. And we're gonna need to get this IPC endpoint right here. And we're gonna open the JavaScript, the geth JavaScript console with that. So geth attach IPC : and I'm gonna go and copy paste that. And we've got the JavaScript console, which is what we're going to use to interact with our contract once it's on the blockchain. And this is also where we can play around with our accounts and see our balances, send anything, call anything, basically whatever we want to do to interact with the blockchain, we can do it from the console. So what I'm going to do is I'm just going to do f.accounts to list my current accounts. And I'm going to go ahead and take this first one. And I will go ahead and keep that right here. Let's go ahead and I'll just put this in a comment for now. Okay, perfect. So we've got the transfer total, we've got the project wallet. Now, all we need to do is get the min max and when the start end, or we just need to declare those variables as well. So let's do uint public constant, and we'll say the max goal amount for this project, we'll just say it's 5 ether. And that ether, the word ether is actually it's a variable that I can access within Solidity. And it just allows the amount to actually be 5 ether in way. And that does the magic for us. So I'll do public constant min goal amount here. And we'll say the minimum, let's say it's 2 ether. And we also need when this contract will start and end. So you'll do uint public start block and end block. And we're going to do this by block. And we're going to do this by block times, or block number. So every time this gets this contract gets called, we're going to read the current block. And if it's not the specified block that we're going to give it, it's going to error out, depending on whether the contract is opened or closed. So with that, we've got our variables going. So now we just need to get the constructor. So the constructor gets called every time, just once, when the contract gets deployed to whether the real Ethereum network or the rinkb testnet that we're deploying to. So let's go ahead and set the project wallet to that address, which is my address, and on the rinkb testnet. And we also need to set the start and end blocks for the contract. So start block, and let's actually see what block we're on right now. If we look at the blockchain being downloaded right here, looks like we're on 759.752. So to give myself enough time while I do this, let's go ahead and set this for 759.850. That's probably a good number. 759.850 equals 759.850. And we can do the end block 100 blocks later. So that's how long the contract will actually be open for, 759.950. Perfect. All right, so now we've got the start and end actually of our contract. Now, what we're going to need now is we're going to need a series of methods to check these things, to check whether the max or min amount has been reached, and to check whether the contract, the actual crowd sale has started or ended. So we're going to do, let's write it down first so I don't forget. Check if the crowd sale has started And we're going to check if the crowd sale has ended. And we want to check if minimum goal has been reached. And we want to check if the max goal has been reached. All right. So this is kind of just normal modular programming. We want to kind of try to keep our functions as small as possible. It reduces the surface area for errors and exploits within the system. So what we're going to do here is we're going to just do a check here. See, function has crowd sale started. And we are going to make this private because this is an internal check. There's no need to expose it to the public. And we're going to make it it's always going to be a constant, and we're going to have it return a bool, which is just a true or false. So we're just going to make a check, and it's just going to return true or false, and it'll tell us whether the crowd sale has started or not. And all we're going to do is we're going to do return, and we're going to take this global variable called block, and we're going to take the block number of this global variable. So when this method gets called, it's going to check the current block that it's in, that the call is being made, and it'll take the block number, and it'll say return true if it is greater than or equal to the start block, which is 759850. So this will just check if the block.number is greater than the start block. Right now, the number is 759763. So that would return false, which would mean the crowd sale has not started yet. So we're going to go ahead and do the same thing here. Function has crowd sale ended. And same exact thing, private constant returns bool. And we're going to do a very similar check. We're going to do return block.number. And we're just going to do greater than, because if it's equal to, it still hasn't ended. And we'll do end block as well. There we go. And we're going to do check if min goal has been reached. Function is min reached. And we're going to go ahead and do the same thing here. Constant returns bool. And all we're going to do is we're going to return the total transferred, or transfer total. And we're going to check if it is greater than or equal to the minimum goal amount, which is 2. So greater than or equal to 2. Actually, I'm sorry, min goal amount, not the actual number itself. Min goal amount. So with that, that returns us the check. The minimum has been reached if the transferred total, which we will increment every time someone sends ether to this, if it's greater than the min goal amount, then the min reached will return true. And we'll do the same thing for here. Is max reached, and we'll make it private as well. Constant returns bool, and we'll return transfer total is greater than or equal to the max goal amount. So with these 4 simple checks, that's all we need really to really do the logic for this contract, to be honest. So one of the other things we need to do is we need to implement a fallback function. And what these are, it's just a function that literally just has no name. So it's a nameless function, just like that. And what this happens is we're going to make this be a payable function. So payable means that it's just a keyword that means that this function can receive ether. So this fallback function is going to get called every time someone sends ether to the contract. So this is where we actually implement the logic to determine whether the contract can take the ether, because we need to check a couple things here. We need to check if Crowdsale started. We also need to check has the crowd sale ended. We don't need to check if the minimum has been reached here, but we do need to check if the maximum, if max amount has been reached. And for security purpose, we also need to check if the amount being sent is 0. There are some exploits that have been created due to people sending 0 to contracts. So check if no ether has been sent in this specific instance. Check if no ether. So, and last but not least, if the above passes, the above checks pass, increment balances and transfer total. All right, perfect. So to check if the Crowdsale has started, we're just going to go ahead and do an if statement. And inside the parentheses, we're just going to call the method that checks whether the Crowdsale has started. And that's it. And if it doesn't work, we're going to throw it. And the thing is we want to know if it hasn't started, not whether it has. So what we want to do is we want to error out of this function, this fallback function, if it has not started. So since it's not, I'm going to go ahead and put that there. So that way, if it has not started, we're going to go ahead and throw. So here we're also going to check if the Crowdsale has ended, and since we're looking for a true, not a false, we're going to go ahead and just don't need the not there. And if it has ended, so if this function returns true, then we're going to go ahead and throw it as well. Throw as in error out completely. Now we're also going to check if the maximum goal has been reached. Let's see, is max reached? And if that returns true, we're also going to throw. And we're also going to check if no ether was sent in this transaction. So we're going to use another global. It's called message. And this has several properties. We're going to be using sender and value. Sender is the address of the person sending the ether. So in the instance in which they're calling this contract, message.sender is the person in which, or the address, the account that's actually calling this method. So we're going to go ahead and grab the value. And if the amount of ether that's being sent is 0, we're also going to throw out of this and error out. So if we pass all of these requirements, all we need to do is increment balances, which we're going to take the address, which is the sender, and we are going to increment that by the value. So message.value. So remember, it's a key value pair up here in balances. So we're taking the address and we're just incrementing the int, the amount that is actually being done here. And let me go ahead and make this a little bit bigger for you if you can't see. And okay, and then we're also going to increment the transfer total the same exact way. And I'm going to take the message.value of that as well. So this payable function, remember, it gets called every single time someone sends ether to it. So every single time, all these checks are going to get made, and we are going to, if everything passes as it should, then ether will be sent, and everything will be incremented properly. So we also need another function here. Need to transfer ether after Crowdsale is done, or minimum has been reached. So let's make another function here called transfer to project wallet. And what this is going to do is it's going to make a couple checks. We're going to check. We don't want to be able to transfer unless the minimum has reached. So check if minimum has been reached. And we also don't want to do anything if the balance is 0. Check if balance is 0. And this is the balance of the user actually making the call. So yeah, and if successful, if above checks pass, then transfer to project wallet. That's it. So if the minimum is reached, I'm sure you can guess, it's if the minimum is min reached. Now, if it's not reached, then we're going to throw. That's how we're going to do that. So if the minimum has not been reached, if it returns false, then we are going to error out. And we also going to check the balance of the contract itself. So if this.balance equals 0, we're also going to throw. So if these two checks pass, then we're going to go ahead and transfer the Ether to the project wallet. So if the project wallet dot send, and this is how we actually send it, and we send this dot balance, which is the balance of the contract. And we're going to throw in a protection here, so that way the only person who can actually call this method successfully is the owner, is the project wallet itself. So you have to own the project wallet to be able to make this call. So this protects this contract from any malicious actor possibly trying to steal the funds or anything. So the only person that can actually call this successfully is actually the project wallet. If you're not the project wallet, you can't, it doesn't matter. We're just going to throw error out, basically. So there's only one address, and it's this address that can successfully call this function. And we're going to do one more thing here. We're going to do a refund. A refund in case the minimum amount has not been reached. So we'll do function refund, and we're going to check. There's a couple things we need to do here. We need to check if the crowd sale has ended, because it'll be afterwards. If crowd sale has ended, we want to check if minimum goal has been reached. And if it has been, if both these things have passed, then what we need to do is actually, we need to check the person who's calling this. We need to check if sender has the balance first in the contract using the balances in using the balances mapping over here. And if they do have a balance, we need to reset it to 0. If have balance, reset to 0. And we also need to refund the balance. Refund balance. So to do the refund, all we need to do is make another check here. If, I'm sure you can guess, has Crowdsale ended? And if it has not ended, we're going to throw. So that's why we're going to go ahead and do one of these. And we want to check if the minimum goal has been reached. So is min reached? And if it returns true, then we're going to go ahead and throw, because that means there's no refund. The refund would only work if the minimum goal is not reached. And we also want to check if the person calling has a balance. So we're going to set a variable here. We're going to call it amount, and we're going to take the balance of the message.sender, which is the person calling the refund at that moment. So there's that. And with the amount, what we're going to do is, if the amount is 0, just in case, 0, we're also going to error out, because that way you can't do anything with 0. And if they do have a balance, we're going to reset the balance and balances of the message.sender. And we're going to set that to 0. Just like that. And if once this passes here, then we're going to go ahead and refund it. So we'll do message.sender.send. And we're going to send the amount that we created there. And if it's not the message.sender, we're going to throw it. So that avoids any malicious person, trying to do the refund, and it's not the message.sender, then they cannot get the refund, or they cannot get someone else's refund. So with that, we should have everything we need, as long as I don't have any typos. We are missing a couple things here. We do need to config the truffle.js to the rinkb testnet. So let's go ahead and do that. Let's go ahead and do rinkb, and host stays the same. Localhost. The port doesn't change as well. So 8545. The network ID does change. Rinkb's network ID is 4. And we also need to add a from So that way we always need a like a parent account, like the account that's actually going to deploy these contracts. We need to specify that. And that is going to be my address that I put here. Actually, let's go ahead and grab it from the Crowdsale. So we're making my address the actual project wallet, and it's going to be the wallet that is sending out the contract as well, that is creating the contract. And we also need to put a gas amount. Let's put an arbitrarily high amount. Let's say 2 million gas. 2 trillion, 2 million. Let's do this one time. There we go, 2 million gas. So with that, we should be able to deploy anything. It shouldn't cost that much gas to deploy these contracts to the testnet. So the config is there. We are missing one more thing. We actually do need to create a special migrations file to migrate this contract. So Truffle has a nice create, just like the contract. We're going to do Truffle create migration, and we'll call it deploy Crowdsale, just like that. So with that, Truffle creates a new folder for us right here, and it's migration.js. Now the thing is there's a little buggy here. So what I need to do is I need to change the name of this, and I'm going to take this name, which is the one I saved, plus these numbers. I'm actually going to make it the migration file itself. I'm just going to delete a random character here so that it saves properly. So now I've got two folders. I'm going to delete this one, and I'm going to delete the other folder as well. But first I'm going to drag out this name here, which was exactly the same name that Truffle made for me, but I just renamed it to the actual migration.js file instead of the folder itself. So that's there. I can delete this folder. So all you have is the initial migration that comes when you do the Truffle init, and then this custom one that I did here. So with that, I'm going to create a variable here. I'm going to call it Crowdsale, and I'm going to use these things called artifacts that Truffle provides, and I'm going to have it require the actual Crowdsale object that gets created. And with that, the deployer, Truffle also has something called a deployer. I'm going to deploy it, and I'm going to deploy the Crowdsale object. And this is what actually helps migrate my smart contract to the Ethereum testnet. And you'll see later there'll be a build folder that gets created once I compile the project, and it's just basically a JSON file of a JSON interface of our contract. So as long as everything is good here, should be good. So let's see if this compiles. So let's do Truffle compile. Looks like it compiled properly. This is just a warning. We could ignore that. So with that, let's try to migrate this to the Ethereum testnet. So what we're going to do is we're going to do Truffle network, actually migrate network, and rinkb. And if it migrates properly, oh, nope, it's not going to work. Perfect. Okay, so what we need to do now is before we migrate this, it says here authentication needed, need password or unlock. So that means we need to go to the Geth console and actually unlock the account that is going to deploy the contract, which is this address, and we just need to unlock it. So I'm actually going to set this address to a variable, and I'm going to call it sender, and I'm going to call it sender, and I'm going to use eth.accounts and grab the first one in that array. So with that, we can do personal.unlock account and throw in the sender in there and put in the passphrase, and voila. Okay, so it should work now. If it works, you'll see submitted contract creation here. So this is the hash of the contract. If we want, we can take a look at my account here on the rinkb testnet. And if I search my account over here, can see that we submitted a transaction, and we're just waiting for the network to mine it, actually. So let's see here. It looks like the network actually did mine it. And the way this works, let me show you. So Truffle supplies this migrations contract that helps migrate this Crowdsale contract. And you can do some interesting things where you can basically chain contracts. You can add dependencies to contracts. This is a very basic, straightforward way that we're doing it. But basically, this migrations contract actually helps create the Crowdsale contract. And as you can see, this new folder was built, and it creates these JSON files, which is just basic. Just a basic interface of our contracts that we created. And you can see that for the migrations as well. So with that, let me see here. Now it's deploying the Crowdsale. We can go ahead and look up the migrations one if we want. And let's see here. So yeah, this is the migrations, and it looks like the Crowdsale has been deployed as well. Looks like we just barely beat the Crowdsale, 841. I set it to 850, I believe. So if I want to hurry up, I can actually try to send, yeah, I did 850. So I can try to send, I can actually try to create a transaction to this contract. I do that. I have the sender. I'm going to set another variable called receiver. And the receiver is going to be the contract itself. So I copy pasted the address, and in some parentheses, I'm going to go ahead and do that. And I also am going to set a value. And let's start with, let's just do 1. So let's do amount equals, I'm going to access the Web3 library here, and I'm going to do two-way, and let's do 1 ether. Now this Web3 library just makes this much easier for me. So with that, I'm going to unlock my account again one more time just in case. And I'm on the clock here. I got 5 blocks. Account, sender, magic 1, 2, 3. Okay, so I'm going to do eth.send transaction. Let me see here. And then in here, I'm going to do from, and that's the sender, which is me. We're going to do to, which is the receiver, which is the smart contract itself, the Crowdsale contract, and the value is going to be the amount. So with that, we should be able to send some money to it. And it was right before the contract has opened, and actually a couple blocks right before. So let's see here. Let's actually inspect the contract that was created. So I have it copied here. This is the Crowdsale contract. Now it should have a transaction being sent to it. So I sent 1 ether to it. Now, once it gets mined, as long as it's not 850, it should actually get denied. So let me refresh this one more time and see. It's still pending. Just give it a couple seconds. While that checks, in the meantime, let me set up this for interacting with the actual contract itself. Because we want to be able to transfer the funds once the Crowdsale has finished or we've reached some sort of minimum. So let me actually see here. This should have been mined by now, but it's not. Maybe it's just taking a little bit. We've actually reached 851, 850, so if it goes through, then that's just because the Crowdsale is actually opened. But in the meantime, let's get this contract interacted with, or let's try to interact with the contract itself. So what I'm going to do is I'm going to take the all the code from this contract, copy it, and I'm going to go to the Remix Solidity IDE, which is a great IDE if you're just getting started. It actually compiles everything for you instantly. And the only thing we need from here is we're going to click Contract Details over here on the right, and all we need is this ABI interface, and we are going to use that to interact with our contract. So I'm going to take that interface, and in our Geth console, I'm going to type a variable called ABI, and I'm going to set it equal to the interface. So I just pasted it in there, and if you see here, it's just got the variables, it's got the functions, it's got all that stuff, and that's all it is. So with that interface, I'm going to go ahead and set a contract variable and object, and I'm going to do eth.contract. I'm going to pass in the ABI. So this gives us an interface to be able to work with. Now, what I need to do is actually create an instance of this interface that we can interact with. So with that, I have to know where to point that instance to, which is this address, the Crowdsale address itself. So I'm going to say instance, instance equals contract dot at, and I'm going to pass in the address in a parentheses, just like this. So now we actually can interact with the contract itself. Let's check if this transaction went through or not. So it looks like, because we passed it before, this was in block 759848. So because the contract doesn't open until 759850, it actually rejected the ether itself. And I actually sent it from my own address. I didn't check before, but because I was in a rush, I wanted to try to send it. I can do f.getBalance and check the sender. And as you can see here, I've got 14 ETH is how much ether I have here. Yeah, so right now, if I try to send it some ether, it should work actually. So, but first, let's interact. Now that I have the instance of my contract, I can actually check it, and I can actually do some interesting stuff with it. So I can actually take, for example, I can check what the project wallet is. So if I do instance.projectWallet.call, it'll actually return to me the same address that created it. So as a result, I can actually interact with it. I could call, for example, transfer to project wallet or refund if the minimum has not been reached. So let's try to send something to it now. So submit a transaction. It'll take a couple seconds, of course. But there it is. It's getting read. Now it should take it. It should be able to actually take the money itself. So let's check the balance of my sender. So once it gets mined, my balance should be down by 1 ETH, and this should actually have 1 ether up here. So just wait for it a couple seconds while that checks. Remember, it usually takes about 2 to 3 blocks for something to get mined. So by now, let's see if it's good. Yeah, looks like it works. It worked. I have 1 ether in here. Now we still haven't reached the minimum. So if I actually call refund right now, it shouldn't work. It shouldn't work because if we check the refund here, we need to check if the minimum is reached, and we need to check if the crowd sale has ended. So if the crowd sale has not ended, we're going to throw it. So it shouldn't even get past this, but we can call it just to play around with it and see instance.refund. Oops, we need to put a from. So when you're using Geth Web3 like this, or you're using the Geth console, you actually need to put the from. So in here, we're going to do from, and we're going to do it from the sender account, which is my account. And we need to unlock personal.unlock account, sender, there we go. And let's go and try this again. All right. So the current contract has 1 ETH because the contract has not ended. The crowd sale has not ended because we're on block 872. Because the minimum has not been reached as well, the refund will not work. It should definitely not work. In the meantime, I'm going to send it some more ether. So I'm going to change the amount to, let's say 3. Actually, web3 dot two-way. And we'll do 3 ETH and leave it at that. So send transaction. We'll go ahead and send that one as well. So the refund definitely did not go through. I still have 1 ether here. This is just us interacting with the contract. Now we sent in 3 ether here. So after a couple seconds, this should work. And if it does work, then we can go ahead and we can actually call transfer to project wallet. Remember, I had 14 ETH in my account. Oh, it looks like it actually sent. Now I have 10 because it looks like we may have successfully gotten this mined. Yeah, so now we've got 4 Ether in the contract, max being 5. So let's try to call transfer to project wallet, because if the minimum has not been reached, throw, which it has been, and as long as the balance is greater than 0, which it is, it should be able to send this to the project wallet. So it's going to send the balance. This dot balance is the balance of the current contract, and it's sending it to the project wallet. So with that, let's do instance dot, what did I call the method? Transfer to project wallet. Transfer to project wallet. And we also need to put the from. And it'll be from the sender, which is the same wallet. All right. Transaction done, submitted. It's going to take a couple seconds for it to get mined. But once it gets mined, I should actually have the money back in my account. So I can actually check it from here. Once the next block comes in the next couple seconds, it should be good. And voila, I've got 14 ETH, and I managed to transfer the funds. It should reflect here as well. And now it's empty. I was able to successfully do a crowd sale. It reached the minimum. And once I reached the minimum, I was able to transfer the funds to the wallet. And yeah, that is it. Again, if you have any questions, you can ask on the YouTube. You can also join our Slack. You can reach out to me, and if you want to pass me your email, I've got a Slack, or our Tampa Bay blockchain developer Slack as well. And I look forward to seeing you at the next one. Thank you very much.